In this lesson, you're going to learn how to solve a polynomial inequality. In this inequality, we need to determine where x is greater than or equal to 0. So first, let's consider how to use something known as a sine chart to figure this out. And I begin by making a number line. On this number line, I place the zeros of the inequality. This would give me x equals 0. The second factor would give me x equals 5/3, and the third factor would give me x equals -1. So I place each of these on my number line. These are my zeros. I also state the multiplicity of each zero. So 0 has multiplicity of 2, 5/3 has multiplicity 3, and -1 has multiplicity 3 as well, because that factor is there 3 times. And at these zeros, I know that my function is exactly equal to 0. So I want to see where is it greater than or equal to 0. So I'm going to find out whether it's positive or negative in between these values. So what I do here is I make a sine chart, and I'm going to pick any value I want to the left of -1. So I'm just going to pick something kind of easy. I'm going to just go with -2. Now, when I square -2, I get a positive. When I plug in -2 right here, I get 3 times -2 is -6. -5 will be a negative. And when I cube a negative, I get a negative. So I'm going to have a positive times a negative. And then I plug in -2 right here. -2 plus 1 will be a -1. Cube that, and I'm also going to have a negative. So when I take a positive times a negative, my answer here will be positive. So my values over here are going to be positive. Then I select a value between -1 and 0, something like -1/2. If I plug in -1/2 and I square that, to my first factor here, I get a positive. If I plug in -1/2 here, 3 times -1/2 will be a negative. Subtract something and get a negative. Raise it to the third. That will be negative. I then plug in -1/2 here. -1/2 plus 1 will be a positive. And a positive raised to the third power will be positive. So positive times a negative times a positive will produce a negative. So any value in between -1 and 0 will produce a negative value. Continue this, I select any value between 0 and 5/3. So I'm going to pick +1. So if I plug in +1 here, I get 1. So that's positive. 3 times +1 is 3 minus 5 is a negative, and a negative raised to the third power is a negative. And then I plug in a positive to my third factor. 1 plus 1 is 2, cubed is a positive 8. So positive times a positive is also a negative. So my function will be negative here. And then finally, I'm going to plug in something greater than 5/3. I'm going to go with 3. So if I plug in 3, here 3 squared is a +9, so positive. Plug in 3 into the next factor. 3 times 3 is 9, minus 5 is a positive. Cubed will be a positive. And 3 plus 1 is 4, cubed will be a positive. So my function will switch back to positive. Now that I have my sine chart filled in, I can see that my function goes positive, negative, has a 0, negative again, positive, and the question is, so where is it greater than or equal to 0? Well, greater than or equal to 0 is where is it positive or 0. So it's positive here and in this region. It's equal to 0 here, equal to 0 here, and positive in this region. So I'm going to state this solution set now in interval notation. So from -infinity to -1 inclusive, union 0, union 5/3 to infinity. Now for just a second, think about this as if it were a function. So on the left, if this were the function f of x, and I'm saying where is f of x greater than or equal to 0, think about what you know as far as end behavior and zeros. So you know that your zeros are at -1, 0, and 5/3. This function would have an even degree. Its degree would be 8, and its leading coefficient, if I multiply x squared, 3x, and x cubed together, actually make that 3x cubed. 3x cubed would be 27x cubed. 27x cubed. And then we have an x squared, and another x cubed gives me 27x to the 8th. I have an even function with a leading coefficient that's positive. So if it has multiplicity 3, I know it needs to cut through -1, needs to bounce off 0 because it has even multiplicity, and then cut through 5/3. So just by looking at this, I can see again that, you know what, yeah, it's negative in this region between -1 and 0 and 0 and 5/3, and then it is positive off on the ends. So understanding the end behavior will help you get your solutions as well. In the next inequality, it is factored again. So my zeros would be -5, and this has multiplicity 2. And then +4 has multiplicity 3. So before we even do a sign chart, let's see if we can figure this one out by end behavior. So this degree would be 5. My leading term would be x to the 5th, which I would get I'd get an x cubed here and an x squared here. That since my coefficient is positive and it's odd, I know my function's going to do something like this. Because it has multiplicity 2 at -5 and multiplicity 3 at 4, it's going to bounce off here and cut through here. So that tells me that it will be negative, negative, and then positive to the right of 4. Now let's actually verify that with a sign chart. And then you can kind of latch onto whichever logic works best for you. So for my sign chart, I'm going to pick something to the left of -5. I'm just going to go with -10. And I'm going to plug in. When I do, I'm going to get -10 plus 5 would be -5, square that, and I'll get a positive. And then I will do -10 minus 4 is going to be a negative, to the third would be negative. So I get a negative result, which is what I said by considering the graph. Something between -5 and 4, I'm going to pick 0. 0 plus 5 would be 5 squared is a positive. 0 minus 4 is a negative. Raised to the third would also be negative. So I'm going to get a negative answer, which is what I stated. And then anything larger than 4, I'll go with +10 on this one. So 10 plus 5, square that is positive. 10 minus 4 is going to be positive. I'm going to get a positive times a positive to get a positive answer. So where is my function this time less than 0? Well, it is less than 0. Sorry, switching tools here to the left of -5. And between -5 and 4, I need to point out that it is equal to 0 at -5. So you need to be careful as you state your solution set. My solution would be -infinity. And it just parentheses on infinity, -infinity to -5, but -5 is not included. Union -5 to +4. Try this one using either method. Hit play when you're ready to check your answer. When you go to find your zeros in this one, hopefully you realize that this would give you two complex zeros, positive and negative I. So the only real 0 would be +5. The leading coefficient here would be x to the 5th. Since it's positive, if I considered what the corresponding function looks like, the end behavior is going to look something like this. It's going to wiggle around a few times in the middle. This has multiplicity, this 0 of 5 has multiplicity of 3, so I know it needs to cut through right here. So that tells me that it's going to be negative to the left and positive to the right. You can verify that with a sine chart. Where is my solution set then? When is it less than or equal to 0? That would be from negative infinity to positive 5. In our fourth and final one, you're given a cubic function that's not already factored. So you're going to have to use your previous factoring methods to get started here. I suggest you could list all your P's and Q's and find a possible rational zero, but we have technology, so it's a good idea to throw this as a function into your graphing calculator. And when I do, it looks to me like there is a 0 at -2, so I'm going to verify that using synthetic division. I bring down, multiply, add, multiply, add, multiply, and I get 0. So -2 is indeed a 0, and then that would give me x plus 2 is the corresponding factor times the depressed remaining polynomial would be 2x squared minus 11x plus 12. And I'm looking where is this greater than 0, and I'm going to see if I can potentially factor this trinomial further. I'm going to go with 2x and x, factors of 12. I'm going to try 3 and 4. The outer term would be -8x, inner would be -3x, adds to -11x, and then my last, product of my last, -3 times -4 is is positive 12. So this works. So from this point, I can set up my number line, and I'm going to place my zeros on my number line. So -2, 3/2, and positive 4. And now you're either going to make a sine chart or use your knowledge of cubic functions and end behavior. So the fact that my leading coefficient is positive, I know that my end behavior will look something like this, and the fact that it's odd. And each of these have multiplicity of 1. So that means we'll have a sign change on either side. So it's going to start negative, switch positive, go back to negative, and switch to positive again. Now I can state my solution. I'm looking for where is this greater than 0? Not equal to, but greater. So greater is, let's see, here and between here. So my solution set would be from -2 to 3/2 union 4 to infinity.